Okay, this is lesson 5.6, the last lesson in this chapter. Yay! And it's half-angle identities. So let's say, for instance, that you're interested in finding the cosine of 15 degrees. Well, that is half of an angle you already know. So it's half of 30, so I could write this as cosine of 1/2 times 30 degrees, right? Because that would be a 15-degree angle if I did that. Alright, so let's say that I did that. Let's say that my angle is 15 that I'm looking for. So if you notice up here, cosine of a 30 divided by 2 is 15. So this is a 15-degree angle, because that's what I'm looking at here. So in order to get this to be a 15, this has to be a 30. So 30 over 2. So A needs to be 30. So this is going to equal plus or minus the square root of 1 plus the cosine of 30 over 2. Okay? Not too bad. Alright, so the cosine of 30 is square root of 3 over 2. And then that's over 2. And this is still under a radical sign, and it's plus or minus. Now we decide whether it's plus or minus depending on what quadrant we're in. Okay, so that's pretty important to know. We are going to be in the first quadrant there, so we know we're dealing with the positive rather than the negative. Okay, let's keep going from there. Let's add these together. So I've got 2 over 2. So 2 over 2, okay, and that allows me to bring these together into one fraction over 2, and that's over 2, and we're still in the radical. Okay, that's 2 over 1, so I can take this and invert and multiply. So I've got square root of 2 plus the square root of 3 over 2, and again I inverted and multiply, so I'm just going to write it out here. And that gives me 2 plus the square root of 3 over 4, and again we're still in the radical. Square root of 4 is 2, and I am done at that point using my half-angle identities. Alright, for this next one, example 2, they want us to find the exact value of that, and they're specifying which of the identities they want us to use. That one right there. So, since 22.5 is half of 45, we're going to replace A with 45. So this is actually tangent of 45 over 2, because that equals 22.5, and that is the sine of 45 over 1 plus the cosine of 45. So sine of 45 right there is square root of 2 over 2 over 1 plus the cosine of 45, which is also the square root of 2 over 2. And then that will, some of that go away, equal, oh goodness, what am I going to do with this? We're going to make this into 2 over 2. So I've got square root of 2 over 2 all over 2 plus the square root of 2 over 2. And the reason I did that, I needed one fraction. Over here I had a fraction and another number. I needed to combine those so that I can flip them over and multiply times up here. Okay, so now I can multiply those together and get, and let's put the answer down below, 2 square root of 2 over 4 plus 2 square root of 2. Actually, no, I don't want to do that. I'm going to leave it the way it was. I'm going to leave it as 2 times 2 plus square root of 2, so that I can cancel that and that, and now I have square root of 2 over 2 plus square root of 2. Now if you remember conjugates, 2 minus the square root of 2, 2 minus square root of 2. See why you learned those? Alright, so when we do conjugates then, we get 2 square root of 2 minus 2 over 2 times 2 is 4, 2 times 2, square root of 2 times square root of 2 is square root of 4, which is 2. 4 minus 2 is 2, and I get that. I can factor out a 2 here over 2, and those will cancel, and I'm left with this right there for an answer. And I'm done. Alright, so what they give us for example 3, they give us the cosine of s is 2/3, and they say that the angle is somewhere between 3 pi over 2 and 2 pi, which means it's going to be in quadrant 4 here, because this is 270, this is 360. So 3 pi over 2 is 270, 2 pi is 360. So I know s lies in here somewhere. Alright, but I'm not interested in s. I'm interested in s over 2. So whatever s is, if I take half of it, where am I going to be? Well, if I'm at 270, or let's just say 280, half of that is going to be 140 in here. If I'm all the way up to, say, 340 degrees, that's 170, so I'm over here. So every half of this is going to put me in the second quadrant. So that's where I'm going to be as a second quadrant point. That is awful cool looking. I need to get rid of it. Alright, so I know I'm in the second quadrant. So let's find the, well, the book finds the sine of s over 2 first for some reason. So let's go ahead and do that. And we know that in the second quadrant, sine, all students take calculus, sine is positive. So we're going to use, let's see, which formula shall we use? We're going to have to use that one, aren't we? So the sine of s over 2 equals plus or minus, but we know it's positive in the second quadrant, so we don't even have to worry about that. We know it's going to be a positive. Square root of 1 minus the cosine of s, which we've already determined is 2/3, so I don't even need that. I can just put 2/3 over 2. So do the math here. Square root sine 3 over 3 minus 2/3, common denominators over 2. So we get 1/3 over 2, radical, equals, that's 1, invert and multiply, and we get square root of 1/6. Cannot have a radical in the denominator like that, so we have to multiply square root of 6 over square root of 6, and we get square root of 6 over 6 for an answer there. So the sine of s over 2 is square root of 6 over 6. So let's see if we can erase all this. I don't know how much of it it'll even erase. Okay, so we were able to find out the sine of pi over 2 without too much trouble, and that was square root of 6 over 6. Alright, let's look yellow. Cosine of s over 2. Cosine is negative in the second quadrant, so I'm going to have negative square root, and I'm using cosine. 1 plus the cosine of a, which we already said was 2/3 from up there, so I don't need that. I'm just going to put 2/3 over 2. And I do the math there, and I find out that this is negative square root of 5 over 6, which is the same as negative square root of 5 over square root of 6. Again, multiply to get rid of your radical signs, so I get negative 30 square root of 30 over 6, and that ends up being my cosine. Alright, last one we're going to do has to do with tangent. And what did I say the cosine was? Negative square root of 30 over 6. Alright, so tangent of s over 2. I've got a couple different options there. So for tangent, we can do about anything we want. I prefer that middle one, sine of a over 1 plus the cosine of a. The only thing that's a little bit tricky here is we don't know what the sine is. We do know cosine is adjacent over hypotenuse, but then we have to use Pythagorean to find out what our sine is, or what this is here, so that we can take the sine. So 4 plus x squared equals 9, x squared equals 5, so x equals the square root of 5. So this is the square root of 5. Alright, so now I've got my sine of s and s, so I'm going to have opposite over hypotenuse, square root of 5 over 3 over 1 plus the cosine of s, which is up here. Okay, so I got the square root of 5 over 3, and I've got 5 over 3 here. When I add those two, multiply by 3/5, and I get 3 square root of 5 over 15, and that cancels with that, and I get square root of 5 over 5. And remember, tangent is negative in the second quadrant.